talk to you and have you understand. There are a couple who were signed up before, so I'll stop you at 15 to go through the gate out here.
Calling a decommissioning support building, and the reason we need to build that is inside, you'll notice, is very cramped and it's hard to do work. So one thing we want to do is package the radioactive material and then get it out of the building so we can continue to do work. And then as that material is staged here for shipment, then we can bring a truck. We'll fix this road up a little bit and bring a truck over here and then ship that radioactive material off site. And if you have any questions, we can explain it. Here's some of the boxes. Those boxes are empty, but that's what an LSA box would look like, what they call a low specific activity box. Actually, that's a half a box. An actual LSA box is about twice as high as that. So you can imagine just 2 of those would be a box that we would use to ship out material. We also ship stuff in 55-gallon drums, and you'll see some yellow drums in the building. I'll point them out to you also. So we're going to build a building here, and also what we're going to do is put another little building ahead of it. The building, the size itself of the building is going to be 40 by 60 foot, and it's a sort of like a butler building. You know those blue buildings you see with the white roof, industrial buildings? That's the kind of building we're going to have. And then we're asking the NRC for permission to cut a hole inside the containment vessel so we can transfer materials back and forth without worrying about the weather. So there'll be a hole right about where that pile of dirt is on the other side of that. It'll be about 12 by 12 foot. And you'll see it on the other side. There's a little hatch, open hatch that will allow us to take material. Also, we're building this an 18 by 24 foot building, and that's going to be used for personnel so they can dress in radioactive material, anti-contamination clothing, and then go into the building. We'll have sort of like a little tunnel that goes up to the hatch so we can go in and out of the building regardless of the weather. We won't have to worry about rain, snow, cold. Now right now the building's kind of hot, but we do plan to air condition it so it will be cooler to work because we're worried about industrial safety. It's very difficult to work in high heat and humidity. So we'll be able to get the temperature down, I hope, to below 70 degrees. If not, we'll have to add certain heat restrictions to that stay time. So if, like I say, if you have any questions before anything about this DSB or something, I'll be glad to answer them now. We'll go in the building. Like I say, it's posted radioactive materials area. We'll go up here, and if everybody can kind of gather up on the top of that step before we go in, and I'll explain a few things while we're up there. It says the material you'll see, or you'll be in contact with, actually is fixed on the floor. Now, not only is it fixed on the floor, but we have what we call yellow Herculate or Griffalon material that's over that to prevent the contamination even from coming out. So you won't be in any contamination areas at all. Just a reminder that eating, drinking, smoking is prohibited, and I just talked about the contamination area under the Herculate. That's also another name for Griffalon. And we'll go in. This is where I'm talking about. This is a head knocker. Please watch yourself. And these are toe bangers, so please watch yourself. There's one here, and then there's a set here. This wasn't here during operations. This was put in when we refurbished the polar crane back in about 94. It was put in to allow us to send big, heavy pieces of weights into the building so we could load test the polar crane again. The polar crane is load tested to 20 tons. So you had to send that kind of weight in to test it. So this was built so we can get that weight in. They said, be careful coming through here. And then the same way, there's another hatch on the other side you just have to be careful of. There's a head knocker. And then the floor is a little shaky, but it is sturdy, okay? So follow me. Trip right here, it's a little wobble. Stand right here. You can move right there. Right? Come over this way. You get in the group. We'll go behind you. I'll give everybody a chance to do it in here. You can come on this side. This is it's steel, and I believe it's 11/16" steel. And the weight of the polar crane is actually on the shelf. That's what we like to hear. Anyway, for me, they have to prove to me they can hold it. I just don't go with Perry. You've been listening to Perry Carmel. Don't worry, Art. Anyway, this is the inside containment vessel. As Joe pointed out in the picture, we're standing on a concrete slab, and below us is the primary compartment. That's where the steam generator is, and what they call the pressurizer and the main coolant pump. And it was access through this hatch here. There's a big hatch that the components went in when they were building it. So you can see the components, even though we call them large, they're only the maximum about 8 foot wide. But they are kind of tall, about 23 foot for the generator in terms of feet. Behind me here are those concrete shields that covered the reactor during operation. There's 7 shields that were in place. These are 2 of them that were removed so we could go into the storage vault and do radioactive characterization so we know what we have before we can get rid of it. There's one on top of each other, on top of about right here. Each one of these weighs approximately 20 tons. Fortunately, the crane is rated for 20 tons. These are about 19.5, so we did have a little lead. I mean, it wasn't exactly 20 tons. And you can see the thickness of them or so, and how wide they are, 13 feet or so, long. Yeah. What we'll do, there's the polar crane up here. That's rated for 20 tons, and it's operational with the main hook. There's an auxiliary hook up there that is not in operation, it's not serviceable. We'll go over to this side, and you can look down a little area, and on your left, you'll see like a black ring that has these big studs on it. That's the reactor vessel. Only a few people can see it at a time, and I won't be able to talk to everybody. So when you look down, just look over to your left and you'll see it down there. It's not very large. And I'll point out some other stuff as we go along on this side. That noise here in the background is that radiation air monitor, and it is running. Any questions before we go on further? Okay, let's go around this way. I'm pointing it out there. Here we go. Of course, the pole is in the way, but you see it, then you can go back there and I'll just start talking about it. You can get in and you can see there's the reactor vessel. Electric wire and insulation, then it was all copper jacket. It's really amazing, but it's an electrical wire. What for? Bring up, operate all the system. Okay. Right now, it's like concrete, really. Yeah, it's flexible concrete. Oh, the generator was that. They put the steam out, out to the steam plant, but they sold ground pumps and stuff like that. But all that electricity came into the connection, then went down below. Yeah, it's kind of wild. I thought it was instrumentation, like air lines.
That's just about what you would guess at.
Small sample lines.
Strain gauges. Strain gauges.
Okay. Few things to point out. One is that concrete cylinder, which is about 5 foot round, 3 foot up on the floor there. That was to store the reactor vessel head during refueling operations. They would take the head off and then remove the fuel. You needed to put it someplace so you can get an idea how big the head is. It fit on that little concrete cylinder. That little concrete cylinder. That green access door that says equipment hatch, should say equipment access door actually, that was used, that slides up and down. It was used during operation period to take equipment, large equipment in and out. We don't like the setup of that because it goes out to an area that gets kind of flooded. So we didn't want to do that for decommissioning, use that hatch. What we decided to do is we're going to build that building on this side, and we're going to cut a hole, we're going to remove these wires and stuff here. We're going to cut a 12 by 12 foot hole here. And then over here, we're going to put in a trolley crane, a small trolley crane that can pick up 5 or 10 tons of equipment. And we'll allow it to pick stuff up from down below, package it up here, and then ship it out to the fueling support building. The decommissioning support building.
What were all these cables?
These are just electric conduit, basically, 1962 errors. It's a copper jacketed cable, electric cable.
How come so damn many of them?
Well, a lot of electrical needs. There's pumps and
control wiring?
Yeah, some of the wires came through for the control rods and stuff like that mechanism. But it's a strange looking wire.
And that door over there looks like it's pressurized.
Yeah, that
airlock or
was
something.
that exactly right. That's an emergency airlock. Nowadays, in a modern nuclear power plant, the equipment hatch door and the emergency airlock is one and the same. Because what happens there, it's very difficult. There's only one door here. When you get out there, there's another one on the side. During operation. That ring all the way down on the bottom, that's an insulation can that was put over the reactor vessel during operation to keep the heat in. You know, it's not like mirror insulation, if you're familiar with that, but all it is that they carbon steel shell used in the air door to keep
Somebody else down there.
Close enough picture.
You can see it from this angle here, the reactor is hot. There must be the control rods on top. Yeah, that costs a
that
fortune.
copper jacket. Well, I tell you what, we always wish we could recover this because that's a load of copper. But copper is very hard to decontaminate.
Well, it gets right in the molecular structure, huh? That will make sense once you get the background.
The dockers have those little tiny grips in them. Yeah, those little grips. Beep, beep, zap, zap, zap.
Can I check your hands now?
Your watch glows in the dark.
How is it? We'll check. And how old is it?
It's old.
Oh yeah?
Check his watch, Dave.
Check his watch.
Yeah, it's old watch. He's probably.
Maybe not.
Nope.
Nope, it's lost a lot.
Oh, it's an Accutron.
Them old, what kind is it?
We have problems with those old
Accutron.
Those old Seikos are the
Killers
killers.
with the radium dials.
Man, they just,
No. Come on over here, Art.
Let me get through.
Other hand.
they just go bonkers.
Ooh, that's a little cut on your
Yeah,
finger.
yeah, die maker. You got away from me.
Ouch. That finger just got away with
You
it.
know me. I don't touch anything. Okay? I put my feet in there all the time. Okay. Oh,
Next.
I think we're done.
That's all.
Okay.
It's getting hotter by the minute now. Okay.
Okay.
Let's get out of here.
Yes.
An experimental nuclear facility in Bedford will soon be removed. The Saxton nuclear plant has been out of operation for more than 30 years. The plant is set to be dismantled and low-level radioactive waste will be removed and taken to a disposal facility in South Carolina. Today, people were able to see the facility's reactor up close during a public open house. Some people are worried about how the dismantling of the plant will affect their area.
I thought it was very good, very informative. I think it helps people when they actually see the containment building and the vessel not be so much afraid of it.
The project is set to start by the end of this year and will continue through 1999.